Today's lesson is 11.3, multiplication and division equations. Your goal for the day is to be able to solve equations that contain multiplication or division. So it's very similar to what we've been doing, except instead of addition and subtraction, now it's multiplication and division. When an equation contains multiplication, we need to solve by dividing both sides of the equation. So again, we're going to be using the opposite operation. Multiplication and division are opposites, just like addition and subtraction. So in this example, I have 9a equals 54. So remember that when there's a number right next to a variable, that means to multiply. So this problem is a multiplication problem. So I wrote for step 1, it's a little dark, sorry. Step 1, notice that there is multiplication in this problem. So we're going to divide, we're going to do the opposite, both sides by 9. So instead of multiplying 9 times a, we're going to divide it by 9. I'm going to cross that off just to get the a by itself. And then we're going to divide 54 by 9. 54 divided by 9 is 6. So we get a equals 6. But remember, we always have to check our work by plugging in our answer for a. So the original equation was 9a equals 54, so now we have 6 equals 54. 9 times 6 is 54, and the original answer was 54, so yes, we got it right. We're going to try another one. Example 2. Now this one you guys are going to help me with. 18 equals 6d. They are using multiplication here. So we need to do the opposite, which is divide. So 18 equals 6d. We're going to divide this side by 6 to get the d by itself. Remember, that's always the goal, is to get the variable by itself. So in order to do that, I'm going to cross off the 6. 18 divided by 6 is 3. So 3 equals d. Now we need to double check our work by plugging it in. So 18 equals, instead of 6d, we're going to say 6, 3. And we're plugging in the 3. 6 times 3 is 18, which is our original answer. So we know we're right. Now, example 3. 21 equals 3x. So again, this is multiplication, so I need to divide both sides. Now, I know that I'm dividing by 3 because it's right by the x. You always divide by the number that's next to the variable because you want the variable by itself. So here we are dividing 3x divided by 3 to get rid of it. 21 divided by 3 is 7, so 7 equals x. We're going to check by plugging it in. 21 equals 3 times 7. 3 times 7 is 21, so yes, we are correct. Now, we're going to talk about when an equation contains division. When it contains division, we need to solve by multiplying both sides of the equation. So, the opposite, right? In this example, I have x divided by 5 equals 10. This represents division. Sometimes I will if it's on a computer, it might just have a slash, like x divided by 5. Sometimes it'll look like that. That just means divide. So x divided by 5 equals 10. This is division, so in order to solve it, we need to use multiplication. So I'm multiplying this side by 5 and this side by 5. When I multiply this side by 5, that's another way of just getting rid of the 5s to get the x by itself. So now that the x is by itself, we have x equals 10 times 5 is 50. X equals 50. But we're going to check our work, like always, by plugging it in. So we're going to replace this x up here with a 50. So 50 divided by 5. Let's see if it really does equal 10. 5 goes into 50 10 times, so yes, 10 equals 10. That means we were right, and x is 50. Okay, and one more example that you're going to help me with. 15 equals r divided by 2. Since this is division, we need to use the opposite to get the r by itself. So instead of r divided by 2, I'm going to multiply by 2 to get rid of it. We're going to multiply by 2 on this side. 2 times 15 is 30. That leaves us with 30 equals r, or r equals 30. So now we're going to plug 30 in where that r was. 30 divided by 2, we need to see, is it 15? Yes. 2 goes into 30 15 times, so we were correct. 15 equals 15.